Now we are in the Matlab environment. We are ready to define initial condition script file, and initial condition we will have all the state variables. So let us write down all the state variables. For the comment we need to write percentage sign, and we define the initial conditions of vehicle. Okay, in our case that is airship. So first we need to define the forward velocity, backward velocity, and all three components of velocity. So basically initial velocity in u direction. So since it is initial, we are defining at 0 because time start from 0. So initial condition we are defining u naught as 0. Suppose we are giving the velocity 10 meter per second, and we need to write the semicolon to stop printing in the command window. Now we have velocity component v, say 0, w naught, say 0. Now we have defined the initial velocity components. Now we need to define the Euler angles and body rates. So first we will define the body rates, and we use s p. Say and there is no body rate at present, and steadily it is moving in state direction. So there is no body rate, only thing is forward velocity is there to the vehicle. Now we have defined pq, p naught, q naught, and r naught. Those are the body rates in x, y, and z direction respectively. And then we need to define the Euler angles or initial orientation of vehicle. And we are assuming right now our vehicle is moving at steady state at some level, and it is not having any angular change at all. So all the component phi naught, theta naught, and psi naught will be 0, and psi naught will be 0. So now we have defined the another three state variable, which is Euler's angle, and we forgot to mention the naught here. Now all initial conditions are defined. Only with respect to earth frame we need to define the position. So suppose your vehicle is at the very top of your earth frame, only having altitude around 100 meters. So we can have x e naught 100 meters, and because our system is like a coordinate system is downward is plus z, so altitude wise it will be negative minus 100 meters, and then after that we will have y e naught. We are assuming at the very vertically on top of the system, so there is no y e naught and there is no z e naught. So all the position with respect to earth is only having the altitude, not any other thing. So this is basically altitude in meters. I have slightly modified the conditions over here, and variable names I have changed, introduces as for no any cross mismatch between any variable in during the script development of nonlinear dynamics. So that is why I have defined. So initial velocity vector as u naught, v as v naught, as w naught as this. So those are in meter per seconds. Then sp naught, sq naught, and sr naught radian per second, and s phi naught, theta naught, and psi naught, which is Euler angles in radian. And then finally x e naught, s x e naught, x y e naught, and x z e naught. These are in meters. Those are very important, and keep in mind the units are in radian by default, and we are going to use the radian unit only. So it is important to mention the unit also in meters, and we need to define here, we need to define the name of the file. So we have initial conditions for airship. Okay, initial. So we have defined the initial conditions of the airship, and we are going to save in this folder over here. So initial condition files we are saving over here. Now keep in mind that the directory is very important for us, so we'll note down the directory to our some preference location where we can continuously go and check everything again and again. So we have the directory over here. Now we will do what we will do, we'll create a note, sticky note, and in the sticky note we'll add the directory. So we'll add the directory, and then it is going to save it. Now whenever we need the directory, we can go to sticky note and then clearly see where we are working. So we'll just run and see how the results are coming. Since everybody having the comma behind it, so nothing is visible. Now we can remove the comma and see the command. So here, as you can see, u naught, which is in the meter per second, is now visible. So this is how we define the initial condition. Now each time if you are going to run your code, you need to first load these initial variables, which will come in your workspace over here, as you can clearly see.